So in this video, we're going to work on finding and verifying the inverse of a function. So now let's put it all together, right? So we talked about how to find the inverse given a function, and then we also talked about how to verify whether two functions are inverses. So we're going to tie all of this information together in today's lesson. So here's how we find and verify inverses. So first we're going to go through all the steps of finding the inverse. So we're going to replace f of x with y, and then we're going to switch x and y and solve for y using our inverse operations. And then remember, if the inverse is a function, we're going to use inverse function notation. Then we're going to do the composition of both. We're going to do f of the inverse and see if that equals x. And then we're going to do the inverse of f of x and see if that equals x. So if both of these compositions are equal to x, remember, then the functions are inverses. So remember, these are inverse operations that we use whenever we need to undo something that's in a problem. So if the original problem says to add, we're going to undo it by subtracting. And remember that generally we follow the operations in this order. It's kind of like reverse order of operations, but we may need to adjust the order a little bit depending on how our problem is set up. So let's find the inverse of f of x equals 5x minus 30 and then use compositions to verify that we have correctly found the inverse. So let's start off by just finding the inverse, okay? So we're going to replace f of x with y, so we have y equals 5x minus 30. Okay, remember now I need to switch x and y, so I have x equals 5y minus 30. And so now I need to solve for y. Well, I'm going to work my way from the outside in until I get to y. So I'm going to start off by adding 30 to both sides. Okay, so I add 30 to both sides, and that gives me x plus 30 equals 5y. And so now to solve for y, I'm going to divide everything in this equation by 5. Okay, and remember when I divide by 5 that x has a coefficient of 1. That's just not written, so I'm going to add that in. And so that's going to give me 1/5 x plus 30 divided by 5, which is 6. And that's equal to y. Well, now what we need to do is we need to check the compositions to make sure we found the inverse. So I'm just going to go ahead and call this g of x so that you know what I'm talking about when I do the composition of both functions. So let's start off by doing f of g of x. Okay, so that means we're going to do f of 1/5 x plus 6. So what I'm going to do is I'm going to go to f of x and I'm going to plug in 1/5 x plus 6. So I have 1/5 x plus 6 minus 30. And so 5 times 1/5 is just going to give me x. 5 times 6 is 30. So I have plus 30 minus 30. And these two terms are going to make 0. So that's just going to leave me with x. So that first part is verified. So now let's do g of f of x. So that means I'm going to take my 1/5 x plus 6 and I'm going to plug in 5x minus 30. So that's 1/5 times 5x minus 30 plus 6. So when I distribute that 1/5, I'm going to get 1/5 times 5x, which is just x, minus 1/5 times 30, which is 6. And then I have my plus 6. My minus 6 and plus 6 are going to make 0, so that's going to leave me with x. So since I verified that these are inverses, and I know my inverse is a function because it's a linear equation, so I'm going to write it using inverse function notation. So we have inverse of f of x equals 1/5 x plus 6, and that has been verified. So now you can go ahead and pause the video and try finding the inverse of f of x equals 1/2 x plus 5, and then using compositions to verify that you found the inverse correctly. So to find the inverse of this function, I'm going to start off by replacing y with x and x with y. And remember, what I need to do now is solve for y. So I'm going to start off by subtracting 5 from both sides, and then I need to undo this 1/2 y. Remember that the opposite of multiplying by half is multiplying by 2. So I'm going to multiply every term in my equation by 2. So that gives me 2x minus 10 equals y. I'm going to go ahead and call that g of x so I can find the compositions. F of g of x is f of 2x minus 10, and when I plug that in, I get 1/2 times 2x minus 10 plus 5. And when I simplify that, that does give me x. G of f of x is g of 1/2 x plus 5, and then when I plug that in, I get 2 times 1/2 x plus 5 minus 10. And that also does simplify down to x. So I can write my inverse now because it's been verified. So I have the inverse of f of x equals 2x minus 10. So now let's try finding the inverse of f of x equals x minus 3 squared plus 5 and then use compositions to verify that we've correctly found the inverse. So remember that we start off by replacing f of x with y. So we have y equals x minus 3 squared plus 5. And now I'm going to switch my x and y. So I have x equals y minus 3 squared plus 5. So now I need to solve for y, but I need to work my way from the outside in, right, until I finally get y by itself. So I'm going to start off by subtracting 5 from both sides because that is the opposite of adding 5. So that's going to give me x minus 5 equals y minus 3 squared. Well, now I need to work on getting y by itself, but everything with y is under the square, right? So my next step is going to be to undo the square power, and I can undo the square with a root, right? Anytime you have a power, you can undo it with a root. So that's going to give me the square root of x minus 5 equals y minus 3, okay? Because the square root and the square are going to cancel each other out. So now all I need to do is solve for y. So I'm at my last step now. I can just go ahead and add 3 to both sides because that's the opposite of minus 3. So be careful when you add 3, okay? Because I've taken the square root already, okay? I've already taken the square root of x minus 5, and then I'm adding 3. So that 3 needs to go outside the square root. That 3 cannot go inside the square root because the square root has already happened before we add the 3, okay? So it's very important to notice that. So now I'm going to go ahead and write my g of x. So g of x is going to be the square root of x minus 5 plus 3. And now I need to verify my inverses. So let's start off by figuring out f of g of x. So f of g of x is going to be f of the square root of x minus 5 plus 3. So what I'm going to do now is I'm going to plug that into f of x. So that's going to give me the square root of x minus 5 plus 3 minus 3 squared, and then I have my plus 5. So you can already see here this plus 3 and minus 3 are going to make 0. So I can just cancel those out, and then I'm left with the square root of x minus 5 squared plus 5. Well, now, once again, I have these opposite operations, right? My square and square root are going to cancel each other out. So I have x minus 5 and then plus 5. And then my minus 5 and plus 5 will make 0, so that's going to leave me with just x. So now let's go in the other direction, and let's figure out g of f of x. So g of f of x is going to be g of x minus 3 squared plus 5. So I'm going to go to g, and I'm going to plug in x minus 3 squared plus 5. So that's going to be the square root of x minus 3 squared plus 5 minus 5. And then we have that plus 3 on the outside. Okay, so let's work with what we have going on under the square root first. So we have plus 5 minus 5. That's going to make 0, so I can cancel those out. So I have the square root of x minus 3 squared plus 3. Well, once again, notice I have these two opposite operations, right? I'm squaring something and I'm taking the square root of it. So that's going to cancel itself out. And I'm going to have x minus 3 plus 3. And then my minus 3 and plus 3 are going to make 0. So that's going to leave me with just x. So I know that this function is the inverse. So I'm going to go ahead and just write it. So I have the inverse of f of x equals the square root of x minus 5 plus 3. And we have verified that now with compositions. So now you can go ahead and pause the video and try doing this example on your own. So here we're trying to find the inverse of f of x equals x squared minus 4. So we're going to write this as y equals x squared minus 4, and then we're going to replace x with y and y with x. So we have x equals y squared minus 4. And then to solve for y, we're going to add 4 to both sides. And then we're going to take the square root of both sides, which gives us the square root of x plus 4 equals y. So to find the composition, I'm just going to call it the square root of x plus 4. I'm going to call it g of x. And so f of g of x gives me f of the square root of x plus 4. So when I plug that in, I get the square root of x plus 4 squared minus 4. So I have x plus 4 minus 4, which does simplify to x. And then for g of f of x, that's g of x squared minus 4. So that's going to be the square root of x squared minus 4 plus 4. Minus 4 and plus 4 cancel, so the square root of x squared is just going to be x. So the inverse of f of x is the square root of x plus 4. And that has been verified. So let's think about this question. Here's kind of a challenging question. So Sarah was taking the SAT, and on that she found the inverse of f of x equals x minus 1 squared plus 4 to be the square root of x plus 1. So first, it's asking us to use compositions to determine whether her answer is correct, and if not, then what is the correct equation for the inverse? Okay, so this is showing you how compositions can be used to check your work. So I'm just going to call this g of x for now so that we can, use compositions to verify. So we have f of g of x. So that's going to be f of the square root of x plus 1. Okay, so what I'm going to do is I'm going to go to f of x and I'm going to plug in the square root of x plus 1. So I have the square root of x plus 1 minus 1 squared plus 4. Okay, so let's see what happens here. So plus 1 and minus 1 are going to make 0, so they'll cancel. So I have the square root of x squared plus 4, and that's the square root of x and the squared are going to cancel each other out, so I have x plus 4. Well, f of g of x, remember, that needs to be x. So we already know that it's not an inverse, so her answer is not correct because it's not equal to x. Okay? So then it asks us to figure out what is the inverse then, right? So let's go ahead and correct this and figure out what is the inverse. Okay, so we have our f of x, which equals x minus 1 squared plus 4. So I'm going to call that y, right? So I have y equals x minus 1 squared plus 4. And then I'm going to switch my x and y. So I have x equals y minus 1 squared plus 4. Okay, so now I need to work my way from the outside in until I solve for y. So I'm going to start off by subtracting 4 from both sides, and then I'm going to get x minus 4 equals y minus 1 squared. Well, now to continue solving for y, I need to take the square root of both sides so I can get rid of that squared. And so that's going to give me the square root of x minus 4 equals y minus 1. Okay, so now to solve for y, I need to add 1 to both sides. And so that is going to give me the square root of x minus 4. Remember that plus 1 needs to go on the outside because we already took the square root. Okay, so it doesn't go inside the square root, it goes on the outside. And that is equal to y. Okay, so that's the inverse we found. So you can see here what it looks like she did incorrectly. It looks like she forgot that minus 4 under the square root, right? She was on the right track, but it looks like she forgot that minus 4. So the correct equation for the inverse of f of x is the square root of x minus 4 plus 1. Okay, so once you've found the inverse of a function, you can verify that you have done so correctly using this relation. If f of g of x equals x and g of f of x equals x, then f of x and g of x are inverses.